So I said I'd give you some help with this. Sorry, my microphone went out. But let's look at what we got to do here. So we want to make a velocity animation, but with angles. Okay, so this is the key here. We got to add angles into it. So we're going to have to do some components of vectors. So we want wind speed, not just wind speed, but also direction, and biker speed and direction. So we have to compute the horizontal and vertical components for both the wind and the bike. And then we're going to display our images moving with time. And so let's see what that. So if we look at what we had here before, I got a bike, and here I'm starting at -10, and then I'm adding on the speed times time. So that's the displacement. That's how far it's going. And so as time is moving here, the bike is going to the right because I'm adding on a positive amount. The guy is just sitting there. The wind here I have, it starting at 30. And then it's moving the other way. It's moving to the left. That's why this negative sign is there. So we need to put that in there. So I just have, let me get rid of some stuff here. We just have the wind and the bike speed, and they're moving based on that. So if I slow down the bike speed, it's going to go much slower. If I speed up the wind, now it's going faster. So we want to use this to visualize the relative motion between the two. So if I put the bike speed at 0, then we can see that the wind is hitting the guy and the bike at the same speed. If I have the bike speed at a positive number, now the bike is moving into the wind, and so when the wind hits it, it's going to feel like the wind's going faster because the bike is moving relative to the wind. And we went over on Monday how to add those in, so we'll do that again later. But first, let's make our calculator. So not only do we want to add the wind speed and direction, but now we also want to add an angle. So I'll just do this. I'll put an A for an angle. It doesn't like other letters. And then we'll do the subscript. So we got the angle of the wind. I'll just start at 0. Oops. We got to get out of there. Equals 0. Okay. And then I'll do an angle of the bike. And I'll set that equals to 0.2 for now. Okay. So now we got to think about if we do give a bike an angle. So we got from the center here, and we're going to give it some sort of an angle. All right. So to find out where it moves, we have to move the box in the horizontal and also the vertical direction. All right. So here's our component lesson here. We are going to give it the angle theta, and we're going to measure all our angles from the positive x-axis. So this is the positive x-axis here, x going that way. And we're going to measure the hypotenuse of this vector, which is the speed. That's going to be the speed of the whatever we're bike or wind. But what we need to do is get the horizontal and vertical components. And so for doing that, we're going to have to use sines and cosines. So remember here that cosine is equal to the adjacent side over the hypotenuse, and sine is equal to the opposite side over the hypotenuse. All right, so if we rearrange these, the adjacent side is going to be the hypotenuse times the cosine, and that'll be the adjacent side to the angle. So that's going to work for right here. That distance here, that horizontal component of the velocity, is going to be the hypotenuse or the speed times the cosine of our angle. And usually we use theta for that. In this case here, we're using AW. That's fine too. And also the opposite side is going to be the hypotenuse times the sine of theta, and that will be the opposite. So that's going to be our vertical because that's opposite the angle. So this is going to be our hypotenuse, which is S, the speed, times the sine of our angle, theta. So that's how we're going to get those two components. So let's put that into decimals here. So now that we have the angles, now I need to calculate the components. And I'm just going to bring this angle. We can move these around. I kind of like putting them next to each other. So we have speed and speed and angle of the wind. We'll put this in here. And now let's do the velocity. I'm going to do the velocity, the wind x velocity. All right. And that's going to be equal to the wind speed times the cosine of our angle, so AW. All right, and so that's the x component. In the same way here, I got to do the y component. So the the velocity of the wind in the y component is going to equal to the speed of the wind times the sine of our angle of the wind. All right. So now I got those, and I'm calculating the components. And we can see here as the angle changes, my components change. One thing that we need to do here, though, the angle, we're going to go from 0, and we'll go to 0 to 360. We'll measure in degrees. And that's the other thing we need to do when we're doing sines and cosine, is to make sure you go over to decimals, and you make sure you're not in radians. We need to be in degrees for this to work, if we're going from 0 to 360. So now I got my angle from 0 to 360. And now I want to make this, that's the wind. So now I need to make the wind move like that. Okay, so I have a starting location for the wind. I'll just put that as 0 for now. And then I'm going to add on, I want to do positives. I'm going to add on the velocity of the wind. So I'm going to put that V, wind. And since here I'm in the first coordinate, which is x, the horizontal, so x times t. In the same way, I'm going to do, for the y component, I'm going to do 0 plus, 0 being the starting point. I'm going to do the velocity of the wind in the y direction times time. All right, so now the x component is changing with the horizontal velocity, and the y component is changing with the vertical velocity. So now we can test this out here. I can change the angle of the wind. So if I go to 45 degrees, now we can see over here that the wind's starting at 0, and it's moving at a 45-degree angle. The nice things about sines and cosines is they keep track of the direction for you. So if I go to 90, it's going straight up. And if I go past 90, now notice here I have a negative velocity for the x because I'm in this other quadrant. I'm going in the second quadrant, which is going to be in the negative x direction. But you can see the wind starting at 0 and moving in that direction. So now I want to do the same thing here, but for the bike. So let's put that in here. We got the velocity of the bike in the x direction is going to be equal to the speed of the bike times the cosine of the angle of the bike. All right, and the same way, I'm going to do the velocity of the bike in the y direction. It's going to be equal to the speed of the bike times the sine of the angle of the bike. All right. And so let's see, now we'll go back up to the bike here, which was this bike one. And I need to do the same kind of thing here. The bike was starting at -10. I'll leave that there for now. And then I'm going to add on the velocity of the bike in the x direction times time. Just one time there, comma. Now I do my y coordinate. I'll just say that's at 0 plus the velocity of the bike in the y direction times time. All right, so now here I got the bike, and I can go down here. I'm going to put my velocity equations just underneath here, so I got all my controls here together. Let's make the bike go. Let's change this again. We got to go from 0 to 360. All right, so now we can make the bike go at a different angle too. So if we got the bike going at a 45-degree angle, and we got the wind going at a 135-degree angle, they're moving around here. So again, I can change where the bike and the wind start. If I want the wind to start further over, I'll just put 20 in there. So now the wind starting at 20, the bike starting at -10, and they're moving in their 45-degree angles, one in the first quadrant, one in the second quadrant. So we can kind of visualize what's going on here. The extra credit was to put in some sliders to change where the bike begins and the wind begins, so they kind of run into each other. So I'll leave that for you to do. So again here, these are our motion equations. You can see how it's the same thing. It's the starting position, and then we add on the velocity times time in the x and in the y direction. And we do the same thing for the wind, the starting position, and then we add on the velocity times time for our displacement. And that should get you that first assignment done.